So this session is prepared by John, who you also see on the video. So John is a senior software staff engineer in Google. So he's the chair of SIG automation. And myself, I'm working in Nokia. I'm heading the technology and architecture. So I'm the vice chair of the SIG automation group. So what we are planning to do in this session is a number of things. First of all, because in the morning we went through a set of these slides, so we want to do a little bit of a recap, but go into a little bit more details in some of the technical topics in order to give you a bit more, let's say, context on what we are trying to do. And then we want to do a demo. So a repeat of what we showed in the One Summit, because seeing is one, believing, but also it probably helps understand a little bit better what's going on under the hood, because there's lots of stuff happening, right? And John will chime in whenever possible. I don't know in terms of questions, so maybe, yeah, given the time, because we have a lot to cover, maybe we'll pause at certain points and then maybe we'll do some questions, and depending on how much we are discussing, we can probably move it to the end or potentially offline if needed. So first, we wanted to start with setting the scene a little bit, which basically is the following: is the focus of Nephio is in the telco landscape. And as so this is a very simplistic representation of what's happening, but we have to deal with a rather complex type of environment, which is highly interconnected, but also is geographically very distributed, right? So in other words, if you look to the problem that Kubernetes tries to solve, is basically doing orchestration of container management within a cluster. Here, the goal that we have, or the ambition that we have within Nephio, is we have to do this across a fleet of clusters that are highly distributed inside of a network. And we have to then orchestrate or automate and handle all the lifecycle management of all of these network functions across these different environments. And as you can imagine, this is a very complicated task, but I believe we have a handle on how to do so. And yeah, during the session, you will see what our approach is and how we are tackling it. Now, the other important thing that we have to understand is so we are dealing a lot with network functions, and in the world of 5G these days, a lot of them are becoming more and more cloud native, but we still have to deal with physical elements, right? So, and we come from a world of the vendor. So me, part of being the vendor side of the things, we have been looking at these function as black boxes, right? So we have been always in the last 10, 20 years developing these as an integrated system, full control, and it was kind of a black box, and you had an open API and stuff like that. And we moved into this cloud, so going first from VNF to CNF, and what you see is that there is still this DNA into our systems that we are highly coupled with infra. Now, that is also a little bit due to the workload itself, because we are dealing with very mission critical things, very high performance. And so as a vendor, you want to control as much as possible the environment in which you deploy in order to deliver that experience. And as a result, what you see also in this journey and to the way that we have gone through it, is that we, as a vendor, what you see today is that they try to do too many things in the infra, whereas they have to deliver the app. And so what we try to do also in Nephio, which is one of the key things that we have done in the demo environment in the One Summit, is we try to decouple and try to say, okay, your responsibility is to deliver a network function, and there is infrastructure people who are been able to deliver other pieces that you need in order to deliver your network function, but you don't necessarily have to control it all. You want to be able to distribute that control to various elements in order to make that lifecycle management easier. And we'll go into more details on those principles, but this is one key aspect that we are tackling very soon into our journey here. The other thing that is important, this is a slide, I used a house, but I could have used islands or something else, is that what you see is that although we talk about 5G, there are separate elements. You have radio, you have transport, you have core, just to name one, and you could even segment it further. But each of those vendors, they try to, going back to the black box principle, try to deliver that as a package and trying to do that in its own cocoon, if you will, and trying to build the best possible house that they believe on how that should be delivered. And the problem as a consumer, you have to integrate all of that. And I started in this journey, I think it was 3 to 4 years ago, when I started to onboard all our network function onto the public cloud. And it was very difficult to do so because I was spending a lot of time in integrating all of these elements together rather than trying to get them deployed and stuff like that. So very difficult environment. And then that is a slide for myself. I came up with the idea because I started to experiment. Can we not use Kubernetes as an operating system, similar to how different applications are being consumed on mobile phone, for example, in order to deliver that job, right? So as a result is use Kubernetes as an operating system and deliver a set of applications that deal with that lifecycle management of delivering those functions, right? And then Nephio came and we said, okay, so that's the right, or we believe this is a very good approach to handle that problem. And as a result, what we are trying to do in Nephio is, first of all, not only focus on the workload, but also on the infra and build a unified management system built on top of Kubernetes. So using KRM, and we'll go into more details of that to do so. So in other words, you have one unified language on which you actually build, or a unified operating system, if you will, how I look at it, on which you build these various functions. So, and of course, you have to divide and conquer. So going back to the previous slide, as we say, specialization versus generalization. Of course, your domain, like the radio or the core, like a UPF or an SMF and stuff like that, still remain specialized territories, but you don't have to control that complete environment on which you build. So, and we believe within the Nephio ecosystem that Kubernetes is that unified layer on which we have to build those applications. And it shouldn't matter whether it's infra or network functions, or, and we discussed this morning, whether it's a physical function or a virtual function, it shouldn't matter, right? And it has the constructs, we believe, to do so. And within Nephio, we actually built some additional capabilities which help or ease that more beyond what we have seen so far, okay? So maybe, yeah, this is a good time maybe to just pause in case there are some questions. If not, we continue. Now, if you look to our goal, which is rather ambitious, right? But one of the key principles that we are taking is we are of this idea of divide and conquer, right? So first of all, we go on to this intent-driven nature of dealing with this. So the declarative way of doing things, focusing on the what, not on the how, right? Of course, as I mentioned in the beginning, we have to deal with this distributed environment. So now, as a result, we have to put in the components in place to do that at scale, but don't create bottlenecks, right? So we try to divide and conquer. So meaning we have introduced the concept of a management cluster, which I'll go into more details, and we want to do as much as possible things up front. But then when we decide, okay, it goes to the workload environment, the workload clusters basically can handle independently of that management cluster, right? So the management cluster basically helps to basically say, okay, this is what I want to achieve. And then the workload clusters act upon themselves. Now, of course, we are building in release 1 a feedback mechanism to basically give information back from the workload cluster to the management cluster. And as a result, we have this closed loop system that we can deal with. But an edge environment, once we decided to go to the workload cluster, there's basically independence of operation at that point in time. And as such, that's a way that we can achieve that whole distributed actuation and basically have that distributed scalability type of environment that we need for this use case. A third element, which I'll go into a little bit more detail in, is basically that uniform system, right? So why do we want to leverage that? It's like we all speak English, right? So if everybody talks the same language, it is much easier to communicate and to build that system where you have various components that actually loosely coupled interact with each other. But also there is things in there, we talk about shift left, so we can use that to basically pre-validate things and try to avoid human error and stuff like that. So if you have a unified language, we want to basically build capabilities inside of the system on which we can actually validate and do as much as possible ahead of time and allow CI systems to basically kick in and validate whether or not they are happy with the result that came out of a certain pipeline, right? So all of these things are important to build that very distributed lifecycle management system. And these are the things that we are building upon. Now, I also created this slide because we talk about KRM and Kubernetes and stuff like that. Of course, we don't want to reinvent the wheel, right? Because there is a lot of systems already available. But I think to set a little bit of a context of an analogy to what Nephio is trying to do versus what Kubernetes is trying to do, the way I describe it is that in Nephio, at this moment in time, our currency is network functions, whereas in Kubernetes, it's pods, right? And we schedule them on clusters, whereas in Kubernetes, we schedule on nodes, right? So as you already can see, there is quite some similarities in what needs to be achieved, right? So as such, you will see, hopefully in the demo, a way that we have basically built a scheduler to say, okay, I have a set of requirements declaratively defined of this network function on where it should be deployed, right? And you could basically think about this in the same way as you say, I need a deployment in Kubernetes, and then all of a sudden that pod gets scheduled on a bunch of nodes. Here we have a similar construct or a similar capability where basically we say, I have a network function of type X, and I have a set of requirements, and I would like to deploy that. And there is a scheduler. Of course, at the moment, it's rather simple, but we can make it more sophisticated going forward. That basically helps us to do so, right? And so these are all type of tools that we are building into the system to ease the life for an operator. So as a result, if you declare an intent to say, I need a network function and I have these requirements, with one declarative declaration, you can actually achieve that. And then the underlying system takes care of that distribution, right? So that's one example, but I wanted to basically put this slide here to basically let people understand on the, let's say, currency on which we operate, right? Now, as already mentioned by many people, also in the previous presentations, KRM is what I call the language that we operate upon, right? So that's the base principles on which Kubernetes has been built. So it's API first. We said it's declarative, so you have desired state and observed state, right? And then they built in a set of metadata. I sometimes describe it as an indexing mechanism. So if you want to look up a certain attribute into a system and you have a JSON schema that is very deep, it's easier to basically reflect it in a metadata. So you basically do a lookup with a single key value pair, and you basically can get that data much faster. So all of these capabilities are built in. There is extendability through CRDs, which we use quite a bit. And another very important feature that I've felt is important in this ecosystem is the event-driven nature, right? So basically, when you see that a resource got changed or there is an update, and by the way, this also works for external events, right? So you could, as we were talking about the physical function, one of the things that I did, for example, if you have, for example, interface going down on a physical switch, you could actually get that feedback in Kubernetes to the event system and basically trigger a controller loop to be reconciled. So all of these capabilities are built in. And as a result, I was of the opinion when I started to look at this like 2-3 years ago, that this is the right framework to start building upon, right? And as such, there is a huge ecosystem being developed. And we want to ensure with Nephio that we extend that to what we call the 5G side of things. But of course, there is endless opportunities here, right? And so that's a little bit why KRM, right? So think of it as the language, it's our English that we all want to talk about.
Wim, are you taking questions during the presentation, or do you want us to hold them to the end?
You can do now, unless yes, I'm happy to take them now. Yeah.
Okay. And this might be one of the stupidest questions ever, so apologies in advance, but could you talk, going back to the last slide, and I think that you sort of touched on this as a design principle, but and I know that this was part of some of the earlier presentations as well, but could you talk a little bit about the sort of, it seems as though CRDs are fairly central to sort of the overall architecture here. And could you just talk a little bit about that decision? And I guess let me give you sort of my context for that. You know, I think if we do see sort of like, you know, networking and telecom use cases that really do need to sort of extend the API functionality, because what we do is different and we can standardize that across all of telecom. So this is the sort of like one vertical, you know, sort of extension to Kubernetes. I think that makes sense. I guess one question I have, because it is a bit of an advanced thing to do, is are we falling in the all too common telecom trap of thinking we're a bit more special, perhaps, than we really are? And are we painting ourselves a little bit into a box where we can't use, I guess, vanilla out of the box quite as much? And I'm not saying that it is the wrong decision. Like, this isn't meant to be sort of an attacking question, but could you just, I guess, touch on that a little bit more?
Yeah, so, okay, let me...
And apologize if it's a stupid question.
No, it's not, definitely not a stupid question, because, see, this is where the journey I went through, Heather, exactly that, right? We always think in telco we are special, okay? And, okay, we are special, right? Because the functions that we develop are special, but that doesn't mean that the automation system that goes with it has to be special, right? So what I mean with that is, so why do I say that? Is that, and that goes back to my original slide with the houses, right? If we all try to build our own house, right? And the integration of building streets between them, and they all have their own language and ways of doing things, it becomes very difficult, right? Now, of course, the question is then, what is the most unified language in which you can do that? And of course, a lot of issues that I see, and I've been through the whole journey, so that's why I've gone through the, let's say, pain, or let's say, I looked at it from a telco. Can we do this, right? We have to talk to physical functions. We have to basically, we have YANG models, we have netconf, we have different types of protocols. How does this all work? I can say all of these things were possible within that KRM environment. So I haven't found anything that we could not do. And then I basically internally inside of Nokia, as you know, basically started to advocate this approach, because what you see is that when I started to onboard like telco applications, we spend more time integrating it than delivering the service. And for me, if I look at it, where do we make money from? It's not to integrate, but it's actually to deliver the service. So we have to make it easier for people to get started and consume these things and deploy, right? Rather than trying to figure out what is the best way that they work together and integrate it with our systems and stuff like that. We have to change that and focus more on what we do with it than how they integrate in the nitty-gritty details. Does that
Okay.
answer your question?
Yeah, I think so. I mean, so basically what you're saying is sort of this approach allows sort of makes use of this sort of, I guess, minimal amount of sort of extensions to vanilla Kubernetes ecosystem necessary to solve telecom challenges, basically.
Yes.
Okay.
Correct. Yeah. And so it's very extensible. Yeah. Yes. Go ahead.
Yeah. Sorry. Yeah. So this is an interesting question. There's a couple of things about this. One is that extension point of CRDs to Kubernetes is, I think the question becomes, when are you extending and for what? So with Nephio, we are extending into creating automation functionalities, functions that that aren't part of standard Kubernetes. Sort of like Wim was talking about, he showed the analogy, right? One where you're automating pods, we're automating functions or workloads, but the kind of automation or inputs and the sort of management of those and the operation of those is really different, right? And I think there is a question of when do you automate the lower level things. So Kubernetes has a deployment, right? That's a way of doing a stateless workload. It has a stateful set. It's a way of doing a stateful workload. I would prefer that, like from a falling into the trap perspective, if we say we're going to create a network function stateful set that's special for network functions that does special things, but really there's no substantive material difference between that and a stateful set, then we're falling into that trap. Because we're sort of saying we're so special, we can't use an ordinary stateful set and ordinary primitive. So I totally agree that we should minimize the use of those CRDs and not replace core Kubernetes primitives. And this comes back to there's a lot of discussion about operators, and operators are these things that run on the workload cluster that manage a particular workload. And we need to be careful. They're critical and important, but when we build an operator, which is different than building something like at the management layer that goes across many clusters, but when we build an operator managing a single workload on or a set of workloads on a cluster, let's make sure that it's doing something significantly different than the Kubernetes primitives. And an example not from the telco world, but where we see this is if what your operator does to create a MySQL instance is just create a deployment and then that's it, or stateful set and that's it, or manage in the same way of a stateful set, it's not useful. If what your operator does is with your MySQL deployment is, oh, you want to do a special operation like a backup, I'm going to go in and I'm going to run some commands in there to quiesce the database, and I'm going to lock people out, and then we're going to back up. Now you're talking about operational capabilities that are beyond the scope of ordinary Kubernetes primitives, and it makes sense to have an operator. So this is where we need to be careful, and it's a line you have to hold, because the infrastructure allows you to do whatever you want.
Yeah. Yep. Yeah. And it almost seems as though there's like almost a sort of, I don't know, coming to kind of a particular similar architectural mindset, which obviously this presentation is part of, but here's like where you don't deviate from standard Kubernetes primitives. Here's where you might define an operator. Here's where you extend using CRD in the Nephio layer. And no, that makes sense. Thank you for entertaining the question.
No, good.
Okay, and we try to minimize. We try to minimize, by the way, because the more reusable building blocks we have, as John said, the better we will be, because then they are reusable for various use cases, right? Like if you look at this guy here, the guy that replicates it, what's underneath doesn't matter, right? So we try to build it generically so that it's not tied to network function, but we could use it for other purposes. Yeah. You see?
Yeah, I mean, I really like the answers to the questions that you're giving. So I'll be quiet now.
But there's a lot of work.
Let you continue talking.
Yes, you raised your hand, but is it quick? Because I think we are otherwise not being able to go through.
I just want to ask Heather the question, because she's from OpenNFV, that the network functions were, in her opinion, I'll reach out to her on LinkedIn.
Yes, yeah, please do
Okay,
after,
sorry.
because otherwise I think this, yeah. Now,
Yeah.
so okay, so we talked about KRM. I think the other key concept, so this is basically coming from Google, right? So they pioneered this initiative, is that, okay, this is, so when you look at KRM, it's basically an API and it has a certain property, right? Now, if you look at configuration management as a whole, there is more to it, right? And we all are probably familiar with Helm, right? Or with like templating systems, for example. What they basically do is they build a layer on top of your data, and then you build their own APIs, and you build layers on top of layers on top of layers, right? Okay, so config as data as a principle is a little bit different, in the sense that what they did is they basically said KRM is our unified language, so let's keep that. So let's not reinvent something new, like values files or whatever. And then what they basically did is they added, let's say, a version backend to it. Like we all know Git, but there is also OCI registries and stuff like that. So we have a version backend at the back of it. And then they said, okay, if you really want to do configuration management, we basically have to manipulate some of these attributes and maybe mutate or validate, or sometimes we generate certain things, right? And so what they basically did is we have functions that basically allow you to manipulate or mutate data. And rather than building separate systems to it, we package it all together into a package that basically constitutes all of these things. And that's basically, if I look at configuration as data, so that's lots of stuff here, it basically extends KRM with that capability in my view, a very nice way. If you really experience it, and we will, in the demo, we will show a little bit of it. What is also interesting is that when it executes and you get a result, they call this thing like what you see is what you get, right? So in other words, the result of the configuration action is actually visible to you within the same package, right? So as such, you don't need to have systems on systems on systems. So it's all packaged together, version control. So basically KRM at the moment is you have, so if you have a CRD, you know the last one in the system. Here you can actually basically look at a versioned thing of it. You can then act upon it. And this is why we are introducing also this concept of shift left approach, to be able to leverage that version system to basically do controls upon it, right? So we could run it through a CI system before we apply it to the cluster and stuff like that. So we have a lot of nice attributes that we can leverage with that. So John, you probably want to add on this?
Yeah, I just wanted to sort of say from sort of high level, like this is a big topic we could talk a lot about. We don't have time, but from a very high level, you know, the existing techniques of like Helm and things like that work well at a certain scale. But where they start to fall apart is one at a scale as in you've got thousands of workloads across or hundreds of workloads in thousands, each in thousands of clusters, you know, so you've got hundreds of thousands of instances, all which have slightly different configuration. So that's a scale level they fall apart. They fall apart in what I would call collaborative configuration, where you sort of have to know everything up front, and everybody has to decide all the inputs up front. You can't sort of evolve iteratively and react to one another. It's a generation type of thing. And they fail in day two management. So if I've had customers tell me Helm charts from vendors are useless because they can't, they have to change them. And once they change them, then if the vendor changes their Helm chart, you know, now they have to do some complicated logic merge. So they fail in day two management. If the vendor changes their package, there's no way to easily do it. So the goals of configuration data are around solving these problems at scale. And so we can't get into all the details here, but that's kind of from a big picture goal perspective.
Yeah. Thanks, John. All right. So of course, with that, a very important topic as well is this whole approach of shift left. And I mean, in a nutshell, what it does, and that's also why we have introduced a management cluster that we have, is basically helping us to. You will see that going forward is when you look at automation lifecycle, you basically have your intent, you basically execute or what we call hydrate that information and you get a new result, the more you can validate upfront and you give you the tools to do so, the all we benefit, right? Because when we move something to the runtime level, we want to be sure that it works, right? So these are type of principles that we are building inside of Nephio that allows you to do what we call the shift left model and validate as much as things ahead of time as you can and if you want, right? So of course you are not forced to do so, but we recommend everything you can validate upfront, you should, and then everything you cannot, okay, you have to deal with that during the runtime level. So these are kind of capabilities that actually are enabled through that configuration as data system as well that we leverage, right? Now, okay, so we have, we're doing reasonable on time. So if you look at architecture, so I think Stephen before basically highlighted already a little bit. So first of all, we have this concept of a management cluster, and then we have edge cluster or workload clusters, as I call them, right? And we use the kept system. So we basically work a lot with packages that basically give us input. And so we use packages in various forms, right? First of all, it starts with a vendor package. So for example, if you deliver a set of artifacts for a certain workload, you basically package that through a kept package, as we call it. For example, when you look into the demo, when you install it, all the Nephio components, we basically packaged in a kept package such that when you install Nephio, you basically install a kept package, right? So we consume it ourselves. And then, of course, the second or the third thing that how we leverage it is basically when we define intent, as we said, we want to do the shift left approach, which means that we don't want to just put all the resulting artifacts that we generate from that high level intent down. We want to basically validate that. So what we have done is we created a repo per cluster because we operate at that level. What we are basically doing is when we get that high level intent and when the controllers basically act or the functions act upon that information, we basically leverage a package on a per workload cluster that basically gives a certain result and that people can look at, approve, do CI, do testing, and so on and so forth. So this is kind of high level a little bit on how that system is put together. And of course, you have all the version control and what have you with it. And that's basically an addition to the Kubernetes system that gives you that version storage beyond just the KRM model, which gives you the last thing that basically apply to the cluster. Now, another important attribute here is that we leverage KRM, and a lot of people say okay, everything is put in the Kubernetes API. Leveraging the system, not all the KRM resources that we are producing or consuming, we apply to the cluster, right? So in other words, for example, you will see into the demo that, okay, we have a network function we will deploy on certain clusters. Okay, we need IP addresses, right? At some point to basically connect it to the network and be able to communicate to it. You will see, so the approach that we took is that during that hydration process, that IP gets allocated, gets put into the package, but actually is never applied to the cluster. It actually is used as an intermediate step to get that information and to basically update our deployments that actually contains that IP, or our network attachment definition for multis that contain that IP that will be used at the workload cluster level. So as a result, not everything that we do has to be applied to the API system. So we now can leverage, and we have to use each system in the best possible way that gives us the most scale and so on and so forth, right? But these are all kinds of attributes that we are getting through that approach. Okay. Now, okay, so this I think is my last slide before the demo. So what you will see, so there is two things that we will show into the demo. The first one is basically to give you an idea of how you manage packages and how that whole system works from, okay, I have let's say an external package like from a FreeFireDC, and how you would deploy that inside of various edge clusters. And of course, for that, we not necessarily have to build operators. Actually, Porch, the configuration as data backend, is doing that all for us, right? So we didn't have to build anything. So this came out of the box from what Google delivered as part of the base framework that we built upon in Nephio. The second use case is a bit different. So here what we do is we basically have an abstract intent, which we call a topology of network functions. So we basically say, I want to deploy a set of network functions, as I said into the beginning, and we want to deploy that on a fleet of clusters in a distributed way, right? Of course, the first thing that you have to do is what I call the scheduler. Right? So our deployment is basically, it takes a package. So FreeFireDC was delivered from a particular vendor, which is basically us in this case, so the open community. We leverage that, and one of the first things that happens is we basically see to which clusters this package applies, right? So we basically do that scheduling, that fan out, right? And basically we distribute that information across that various workloads clusters, but still at the management cluster level, that basically says, okay, this function will have to be deployed on these set of clusters. And then through the conditioning system that Stephen explained in the previous slide, we basically, we hydrate that package in a way that we get an end result. And there is various steps or things that needs to happen in order to do so. So for example, we need to allocate IP addresses. We need to basically define network attachment definitions. We need to understand how such a deployment is. And this is all implemented through either controllers that we have so these are things that we have built, or through functions, through kept functions that act within the package, right? And so, as you were asking, Heather, so what we are trying to do in Nephio is, because of course you cannot build with a small team as we have right now, all of these things. So what we are trying to do is make it reusable, make it loosely coupled, and as a result, build these reusable components that are loosely coupled between each other in order to leverage that and unify as much as possible, so that we can leverage not only for UPF, but also for SMF, for AMF, and for other network functions, or even other environments going forward, right? And so that's kind of a little bit what we will demo. So if no further questions, I will switch screen unless there are any questions. Let me first see whether my system is still. All right. Wait. Oh, is it okay? Yeah. So first, so what did we? By the way, is this okay? This screen like this?
Yeah, maybe slightly zoomed if you can.
More zoomed. Okay. By the way, first of all, you will see the links into the screen. All of this, what I'm showing, you can basically do it yourself. Okay. So that's the nice thing. So we basically build an environment, and that is 2 repos, which we'll put it, we have into the slides after this demo. So basically, these are the 2 repos that we built as a community to basically do that. So there is 2 repos. One is the installation. So basically, we install that whole environment. So we use Ansible right now to do so. So all of this is basically running on a virtual machine. And then we have, let's say, a second repo that basically shows how to consume it. Because at the moment we are installing kind clusters. So we leverage kind clusters that are getting deployed. We are installing all the pieces of software onto it and so on and so forth. We interconnect these clusters to ensure that we have the right environment in place and so on and so forth. So all of these things are there. And then this basically repo is kind of indicating how you use it. So you first have to do this, and then you basically consume that. So I did this step already, right? So basically this is done for you. Otherwise, it would take a bit of too long of time. So the first thing that we wanted to show you is the following. So first of all, I have a Git backend, and we have both. We can use standard GitHub. So today we have tested standard GitHub. I'm using the Gitea local installation. So I'm having a local Gitea repo that we also deploy. So you have the choice when you set your environment up to use GitHub or Gitea. And I've deployed in the Gitea, I've deployed 4 repos. So one is a catalog, which basically is, you should look at it. This is the repo on which you, I call it like the scratchpad or your environment on which you leverage to basically install and use, right? And you basically leverage external packages that come from either vendors or from Nephio, right? So you will see 2 external packages that we are delivering. So you see here, we have external blueprints, which are a free 5DC package and Nephio packages. So they contain information. So they are hosted on GitHub, right? So they are not in the Gitea repo. And then we have what we call organizational blueprints, which basically it's what you use or what you consume in your environment to deploy that within your infrastructure, right? And of course, so the first thing that we want to show you is how we get from these packages here, how can you consume them and basically install them on your local environment. So we have built a UI. So this is built on Backstage. Yeah, and the problem is I need to do this. So the first thing what you have to do is you have to create or add a blueprint, right? And you have then the choice, I want to leverage an external blueprint, right? And I want to use free5gc, I want to use this operator, and I go to the catalog, right? You do next, next, next. All right, so you can do much more things, but for the demo, we will go a bit quicker, right? Because of time. So what we are doing right now is we are basically cloning that repo that you have, so which contains that free5gc, and there were 2 packages inside. One was the UPF, one was the operator. And now we have a clone in our own organization, which is stored in the catalog repo, right? And so if you go to the repo itself, I think at the moment you will see a branch. So we'll basically do all that management for you. You see that free5gc operator appearing in here. And now you can say, you could basically say, okay, I validate it. I go and run it on a separate system before I deploy. So you can basically do propose it, where you basically say, okay, I go to the next level, and then you can do an approval, right? So now what you see is that you have that package at your disposal in your organization, right? But it's not yet deployed inside of the edge cluster, right? So what you do next is basically say, okay, we use our fan-out controller, if you will, right? So this is all happening under the hood. So but now you say, I need a package deployment. So what this thing is going to do is I say, I want to deploy that across various clusters. And you basically say, yeah, organizational blueprint from the catalog, and I want this free5gc operator. And then you say, I want to deploy it onto a set of regions. We have US Central here, and we basically say, I want to deploy it on all the edge sites based on that region, right? And so then again, we can skip these steps. So what actually happens right now is that that package deployment, that fan-out controller, if you will, takes this and looks, okay, based on these selectors, which is the region and the edge, right? So basically, I see which clusters do I have available and where should this be deployed, right? So what you see here is that it decided, or it selected basically 3 edge clusters, so edge 1, edge 2, edge 3, right? And it basically says, okay, what do you want to do next? And okay, sorry, yeah. So basically, what you can now say, so this information is again put inside of the repo, right? So you will see here. Yes, sorry. Is there a question? Okay. Can someone maybe mute them?
Got it.
What you will see, is that this also got basically prepared inside of our repo, right? And then you can go to the same steps. You can basically say propose, right, on H1 and approve, right? So what you will see happening if you go, so here is a terminal to actually look at what is actually happening inside of the cluster. So if I basically look at my pods, did I approve? Yeah, you see here that FreeFileDC is getting, so the package, so the operator that basically was associated with that package is getting installed inside of that FreeFileDC operator and will get into a running state based on the information that it gets, right? You see it's up and running right now. So here you get a feel of how you use that whole distribution of software, but even configuration artifacts of how you can actually leverage that within that environment that you set up in order to leverage these concept and native KRM together with our configuration as data and the fan-out controller that at the moment was built as a separate component, but the idea is to actually integrate it in Porch as a system going forward. Okay, so that's the first demo. The second demo that we wanted to show is that demo where we basically go from here, where that high-level intent, you basically say, I want a set of network functions with a set of criteria to say deploy. So we'll use the same criteria as we had here. And basically that network function will actually go through that whole hydration process. So the first thing that will happen is basically it says, okay, on which clusters do I need to deploy it, right? And then the second thing, what will happen is from the moment it has decided that, it basically goes and looks at the various elements that needs to be applied to that package in order to get a deployable state into the system, which basically will be updated into the repo, right? So the first thing that I will need to do is so this is basically, so we'll do that through the CLI. So basically, this is our CRD. Right? So at the moment, so this is proof of concept. So we are discussing to re-architect it or redefine it a little bit. But what you basically get here is, I want a set of UPFs as in the aggregation layer, which means in the edge clusters. And I have a certain capacity and interfaces that I need. But I want to have a selector basically, which is the same selectors as you saw before when we use a package deployment, right? And so the interesting side or thing here is that the way to do that fan-out capability or that scheduling system is the same whether we deploy a network function or whether we deliver a package, right? So we haven't changed anything specifically to do this or that, right? So if I apply, so at the moment what you see is that my repos, the edge cluster 1 here is having the FreeFileDC. So basically this is already available. What you will see in a bit when this works, you will see that actually also UPF will be added to the system. And then we can go through that whole system when I apply that to the cluster. So if I cube apply minus FileDC. So basically now I have created that that high-level intent that describes my network functions and how I want to get them scheduled, right? So what happens right now is that Porch as a system, right, will take that information. First the package deployment will basically look at it, do the fan out, and basically takes that package that was originally there and fans it out over a bunch of clusters, right? And what you will see is that if you if you look to the branches, because I did not commit, you will see that there is a new branch with the UPF function being deployed. And what you see is that we are going through that hydration process as we speak, right? So if you look at this in a little bit, you will see more and more. So if you look to the cap file, you'll see more and more of these things appearing. So here you see that our IPs are not allocated. So you see here the set of conditions that we want to achieve and have acted upon. And so these things will, when you look at the system, will basically get updated along the way, right? So what you see right now is that you see that there was an IP being requested for an N3 interface on the UPF. It got a prefix assigned with a gateway, right? We also have, let's say, hydrated the network attachment definition because we are using at the moment MAC VLAN, but you could use SRIOV or other capabilities as you want, that that network function needs in order to get deployed. So both IPs, network attachment definition for multis, and so on and so forth, are actually put as part of that package that is going to be then selected and once approved is going to be added to that workload cluster on which that package will get installed and that UPF will be deployed, right? So I think, yeah, so that's basically what is happening along the way as we speak. But I hope you get a little bit of a taste of what is happening under the cover in order to basically understand a little bit more of what we are doing and how this thing functions as a whole. All right. So as I said before, I recommend people, if they are interested, to go through the details. So first, as a community, we have basically put 2 repos. So here are the links. So you'll get these slides. So this one is basically the installation. This one is the consumption, as I showed during the demo, right? And both explain to a great level of details, not every nitty-gritty detail, but what I would welcome everybody is join us. So here are a set of resources. So we are meeting at the moment so in SIG Automation, we are meeting Tuesdays at 8 a.m. Pacific and 9 a.m. Pacific on Wednesday to actually have our SIG meetings on which we basically discuss various topics and basically our focus right now is moving up to release 1 to get that going. And with that, I would like and open for questions if there are any.
Can you explain the shift left, what it means concretely?
So what it means, so what I was showing into or trying to show into the demo is when you do, let's say, automation, you basically generate a set of artifacts, right? So for example, in here, the artifacts that we are generating in this demo is a deployment that actually will have to be deployed onto the workload cluster, right? So during that process, so going from that high level intent, we basically generated a new set of artifacts that are a result of that, okay? What shift left means is that we could have done 2 approaches, said, okay, I don't care, everything what we trust our operators 100%, right? Everything that's going on is fine. And we could have applied that to the workload cluster immediately. But so what does shift left mean is that the result of that, we would like people to have the ability to, let's say, validate, run through a CI system. So the result, you could basically say, okay, I first want to run this workload and the additional parameters that you have generated onto a CI system, validate it, test it, run a sort of regression test. And only when I'm happy with the result, I apply to it. So all of these, so that's what we mean with shift left, is trying to help you validate as much as possible ahead of time before going to a runtime environment on which this thing will be deployed. I think, John, you also have your hand.
Yeah, yeah. I mean, what you said is exactly right. I think that another zooming out a little bit, like if you think about the process of preparing something for deployment, you know, we sort of think of the left-hand side being like the planning and the right-hand side being the runtime. And the idea is that if any decisions or values we set at runtime, like by a Kubernetes operator running in the workload cluster, take effect immediately. So if you change a value, it takes effect immediately, which means it has immediate operational consequences. Things that you set or do in planning or in preparing the configuration along the way don't take effect until they hit that runtime cluster. And so we have additional additional opportunities to get eyes on them. It comes back a little bit to Heather's question earlier about like when you have an operator versus when you use a Kubernetes primitive. If you use a CR that then an operator on the workload cluster uses to talk to the Kubernetes API server to create Kubernetes primitives, there's code in there in that operator that could have a bug, and there's no opportunity to do any validation. If instead you go all the way over here and you generate those Kubernetes primitives over here, then you have an opportunity for machine or human validation, as well as other kinds of policy checks and things like that we can't do. So in order to change the one on the right, you have to change code and deploy a new operator, which affects not only that particular workload, but every workload managed by that operator. So there's a blast radius issue too. So these are some of the sort of ideas around shift left. Of course, there are things that have to react to runtime, and so that's not appropriate for those things. But we sort of have to make those judgment calls. Hopefully that helps.
Okay, but I have difficulties to see the difference. I mean, because you are saying that you are giving the opportunity to do CI, CD when you have produced the deployment out of the intent processing, right? That's what basically you are saying. Okay.
Yeah, correct.
Okay.
Yeah. So now you can use it. You don't have to use it, right? So we give you the choices or the tool to do so. Because what I working with a number of operators, they always ask me the question, I want to see the configuration before it actually goes to the network elements, right? Please give me that capability. There's a way to do so.
Okay, I see. Thanks.
And we give you more controls, basically. Or we try to give you more controls to do these type of things. Yeah. All right.
Okay, 2 minutes left. We might have time for one very quick question. Okay, Wim, John, thank you very much.
Thank you.
Thank you, Wim. Thank you, John. Bye.